Hello students and welcome to my channel Maths App. So today in this video, I'll tell you about the application of partial differential equations. So we will start with the first application, that is the wave equation. So what are we going to learn in this video? We will learn what is the physical interpretation of this equation, and then how do we mathematically model it, and then what is the solution of this wave equation, right? So to begin with, let us understand what is the physical interpretation of a wave. So you must have seen a guitarist playing a guitar. So what happens when he plays the string, the strings, the length, the displacement changes every time, right? And the strings are attached at both the ends of the guitar. So if I convert this problem into a mathematical model, so this is the length of the string. We assume that the length of the string is L, right? And both the ends of the string are attached. That means the displacement at both these ends is equal to 0. So we are interested that at time t, what is the displacement in the string? So if I assume that this is an elastic string type which is tightly stretched between the 2 points O and A, so we assume that O is the origin and OA is along the x-axis. So y is the displacement at any time t. So what is the mathematical model of a wave equation? The mathematical model is del square y by del t square is equal to c square del square y by del x square, right? So here y is the displacement of the string, and we are interested in calculating the displacement at any time t. So how do we solve it? So if you have watched my previous video, I told you about the method of separation of variables. So we will be solving this wave equation with the help of method of separation of variables. So according to the method of separation of variables, you can see that y depends upon two functions, two variables, that is x and t. So according to method of separation of variables, we will assume y as a function of x into t, where x is a function of small x and t is a function of small t, right? So according to the problem, del square y by del t square will become xt double dash, and del square y by del x square will become x double dash t. So now let us substitute these values in the given equation. So we get xt double dash is equal to c square x double dash t. And as the method suggests, method of separation of variables, we will separate the variables on both ends, right? Method of separation, it's not separable, so it is method of separation of variables, right? So now we will separate x double dash and x on one end, and we can separate 1 by c square t double dash by t, right? So now you can see that this is a ratio, so I can put this ratio equal to some constant k. Now when we are solving for wave equation, what do we need to understand? That this k can be, what are the possible values of k? K can be a positive number, k can be 0, or k can be a negative number, right? So we will do separate cases for all these three, and then we will choose the best possible answer, right? Now, according to the physical nature of this problem, when the string gets displaced from its original position, what will happen? It will produce some vibrations. So we know that vibrations are always in terms of trigonometric functions, right? So that means whatever solution we get after solving, that must contain some trigonometric terms. So any solution which will contain the trigonometric terms, that will be the best fit solution, right? So let us take this equation and let us take different values of k and solve for different values of k, right? So we do the first case, and the first case is when k is a positive number, right? So we assume that case 1, k is positive. So if k is positive, we assume k to be some number as p square. Now whether p is positive, negative, p square is always going to be positive. So our equation was x double dash by x is equal to 1 by c square t double dash by t. So let us take the first equation, that is x double dash by x, and we are putting it equal to p square. So let us put it equal to p square. So when we frame the differential equation, it will become x double dash minus p square x is equal to 0. So from here I can say that d square x minus p square x is equal to 0. So that leads to d square minus p square into x is equal to 0. Right? So from here, this is a second order homogeneous differential equation. I can make the auxiliary equation d square minus p square equal to 0. So m square is equal to p square. So that means the roots of this equation are plus minus p. If the roots are plus minus p, that means x comes out to be, they are distinct roots. So c1 e raised to power px plus c2 e raised to power minus px. Right? Now let us solve for the second equation. So the second equation is 1 by c square t double dash by t is equal to p square. So now when I frame the differential equation, I will get t double dash minus c square p square t is equal to 0. So from here we can write it as d dash square t minus c square p square t is equal to 0, or this leads to d dash square minus c square p square into t is equal to 0. So from here d dash square minus c square p square is equal to 0. So the roots become m square is equal to c square p square. That means m turns out to be plus minus cp. So again the roots are distinct. So what is t from here? T comes out to be c3 e raised to power cpt plus c4 e raised to power minus cpt. Right? So once x is calculated and t is calculated, we need to frame the displacement y, which is the product of x and t. So we get c1 e raised to power px plus c2 e raised to power minus px multiplied by c3 e raised to power cpt plus c4 e raised to power minus cpt. Now, as I told you that according to the physical nature of the problem, the solution must contain some trigonometric functions. But you can see that there is no trigonometric function, and hence we will reject this solution. That means k equal to positive will not work for wave equation. Right? So now similarly, we will do the second case when k is equal to 0. Right? So let's do the second case, case number 2, when k takes value 0, right? So again our equation was x double dash by x is equal to 1 by c square t double dash by t, and now we take it equal to 0. So the first equation becomes x double dash by x is equal to 0. So that leads to x double dash is equal to 0. So we have d square x is equal to 0. So from here m square is 0. So m comes out to be 0 comma 0. So the roots are real and equal. So what is x? X is c1 e to the power 0x, which is 1, plus we will multiply x and c2 e raised to power 0x, which is also 1. Now let us work out for the second solution. We have 1 by c square t double dash by t is equal to 0, right? So from here t double dash comes out to be 0. So that means d dash square into t is equal to 0. So m square is equal to 0. So what is m? M is 0 comma 0. So from here t comes out to be c3 plus c4 into t, right? So that leads to my displacement as the product of x and t. So we get c1 plus x c2 multiplied by c3 plus t times c4. Again, this is not containing any trigonometric solution, trigonometric functions. So this solution is also rejected, right? So now we move on to the third case. The third case is when k is a negative number, right? Case 3, when k is negative. So when k is negative, let us take k as minus b square, right? So our equation was x double dash by x is equal to 1 by c square t double dash by t, and now let's take it as b minus b square, right? So from here, the first equation we get is x double dash by x is equal to minus b square. So what is x double dash? Plus the differential equation is x double dash plus b square x is equal to 0. So that leads to d square plus b square into x is equal to 0. So the auxiliary equation will be d square plus b square equal to 0. So we convert it into an algebraic expression, and then the roots of this equation becomes plus minus iota p. Now the roots are imaginary. So what is x? X comes out to be c1 cos px plus c2 sin px, right? Now similarly we take up the second equation. The second equation is 1 by c square t double dash by t is equal to minus p square. So from here t double dash plus c square p square t is equal to 0. So that leads to d dash square plus c square p square into t is equal to 0. So from here we get the roots as m square plus c square p square is equal to 0. So m comes out to be plus minus iota cp. So from here what is t? T is c3 cos cpt plus c4 sin cpt, right? So that leads to my displacement y as c1 cos px plus c2 sin px multiplied by c3 cos cpt plus c4 sin cpn, right? Now you can clearly see that this solution contains trigonometric functions. So according to the physical nature of the problem, we will accept this solution. That means we worked for three cases of k positive, k 0 and k negative. So for positive and 0, we rejected the solution because it was not going with the physical nature of the problem. We will accept the solution for k negative, right? Now how to proceed further? Now you can see that the solution contains constants C1, C2, C3 and C4. So we need to calculate the values of these constants, right? So we need some values, right? Now, what are the initial conditions in this after getting the solution? Initially, what is happening to the string? It is fastened at the origin point, right? That means at x equal to 0, the displacement is 0. So this is my first condition, right? What is the second condition? The second condition is at the end point. When the string attains length L, then also what is the displacement? We have fixed it at the x-axis, so the displacement is 0. And what is the third condition? The third condition is at the initial velocity del y by del t at t equal to 0. Initial, it is also equal to 0. We got three conditions. The fourth condition will be provided to you in the question, right? So that depends upon particular question. So till this step, the previous step where we were calculating for k negative and we were getting the solution and applying these three conditions will remain same for every question on wave. Only the fourth one depends upon whatever question is given to you, and accordingly you will get a different value for the constant, right? So let us see how to work with these constants. So now what did I get y as? Y was, the last solution was c1 cos px plus c2 sin px multiplied by c3 cos cpt plus c4 sin cpt. Now you have to take care how do we get the values of these constants. So let us apply the first condition, that is y0 comma t is equal to 0. That means x is taking value 0 and y is 0. So we will get 0 is equal to, put x equal to 0. So cos 0 is 1. We are left with c1. c2 sin 0 goes off and we get the next term as C3 cos CPT plus C4 sin CPT. Now you can clearly see that the first term depends on x and the second term depends purely on t. So now this condition is on the variable x, right? That means there is no change in t. So when we are getting this product, 0 is equal to C1 multiplied by this term. Either C1 is 0 or this term is 0, but this term is unaffected because we are not changing t. So that means what happens? From here we get C1 is equal to 0. So this is the value of the first constant that we get. So substitute it back in the displacement and reduce it. So what is y then? C1 becomes 0. So we get C2 sine px multiplied by C3 cos CPT plus C4 sine CPT, right? So you have to see that on which variable we are applying the condition, and only that part will get affected, not the rest of the part, right? So we have applied the first condition. Now let us apply the second condition. The second condition says y at L comma t is equal to 0. So now we have to substitute this value of y in this. So 0 is equal to, put x equal to L. So we get C2 sine PL. There is no change in t, so we will get the same terms. C3 cos CPT plus C4 sine CPT. Right? Now, what will happen? You can see that this term is unaffected because this is dependent on t. We are only changing the variable here is x. So that means this term has to be 0. So this implies that C2 sine PL is equal to 0. So either C2 is 0 or sine PL is 0. So can C2 become 0? C1 is already 0. So if C2 becomes 0, y becomes 0, right? So it becomes a trivial solution. We are interested in a non-trivial solution. So that means C2 cannot be 0. If C2 is not 0, so what implies? It implies that sine PL is equal to 0. Now which values of sine are 0? Sine n pi, right? So if sine PL is equal to sine n pi, that means what is P into L? P into L is n pi. So we get the value of P as n pi by L, right? So let us substitute P is equal to sine n pi by L in this expression. So y reduces to, y becomes C2 sine n pi by L x multiplied by C3 cos C n pi by L t plus C4 sine C n pi by L, n pi by L multiplied by t, right? So now we are left. So the second condition is also done. Now we are left with the third one. For the third one, we have to calculate the value of del y by del t. So let's calculate. So we will get C2 sine n pi by L into x. And now when I calculate the derivative, I will get cos is sine minus sine. So we will get C3 C into n pi by L, that is the constant, along with sine C n pi by L t plus C4, the constant that we will come along is n pi by L, sine will become cos n pi C by L t, right? Now let us put the initial velocity equal to 0. So del y by del t is 0. So there is no change in now x because now we are changing the variable t. So from here, when I put t equal to 0, sine 0 becomes 0 and this whole term vanishes. And from here, when I put t equal to 0, cos of 0 is 1. So we will get C4 into Cn pi by L, right? So either this term is 0 or this term is 0, but this term cannot be 0 because this is an unaffected term because we are changing the variable t, not the variable x. So that means what does it imply? It implies C4 is equal to 0. So if C4 is equal to 0, the last modified y was this. So let us put That means every time we are applying one condition, we are getting something and we need to reduce the displacement, right? So what is our displacement now? C4 is 0, so this term gets neglected and we will get C2 into C3 sine n pi by Lx multiplied by cos C n pi by L t, right? So this is the value of your displacement till the third step. So that means any question on wave you get till here, the solution will remain same, right? After this, whatever condition is given to you in the question, we have to do it accordingly. Clear? So this is the displacement. So now let us look into one question and see how to proceed. So let's look into the question. A string is stretched and fastened to 2 points L apart. Motion is started by displacing the string in the form y equal to a sine pi x by L, from which it is released at a time t equal to 0. Show that the displacement of any point at a distance x from one end at time t is given by this expression. So that means the condition is given to you, the fourth condition, rest everything will remain same. So from the last slide, we got y as C2 into C3 sine n pi by L into x and cos C n pi by L into t. Now, what is the condition given? The condition given is y at x and t is equal to 0. What is y given to us? A sine pi x by L, right? Now in this condition, what is happening? You are putting t equal to 0. So let's put t equal to 0. So we have a into sine pi x by L is equal to, we will put t equal to 0. So we will have sine n pi by L into x. T is 0, so this term becomes 1. Now when you compare the coefficients on both sides, what will you get? You will get that C2 into C3 is equal to A, and when you compare sine, you will get n is equal to 1. So put these values in y. So y turns out to be A sine pi x by L cos C pi by L t. Right? So are we getting this displacement as required in the question? Clear? Okay. So this was one type of question. Let's check out another question. The next question says solve the wave equation. You are given del square u by del t square is equal to c square del square u by del x square. Now it is given u is 0 when x is 0 and x is equal to pi, and del u by del t is 0 when t is equal to 0, and u x comma 0 is equal to x when 0 is less than x is less than pi. Now, how to change this question according to the given problem? As I told you that the solution will remain same till the third step, right? So in the third step, we got the displacement y, as I'm just writing the displacement here. Y is equal to C2 into C3 sine n pi by L x into cos C n pi by L into t. Now, how will your problem change according to this question? Now, you can see that what is the length of the string given to us? It is not L, it is pi. That means in this, wherever you have L, you will put equal to pi. The next change, you can see that the displacement is no longer U, but it is not Y, but it is U. So how will you write the question, the solution? U is equal to C2 into C3 sine, put L equal to pi, so L pi and pi cancels, we will get sine nx into cos, L and pi cancel, so we get nct. Okay. So now here you can see that the solution is trivially true for all values of n. N ranges from 1, 2, 3, so on. Right? So I can write that this is true for all the values of n going from 1 to infinity, and C2 into C3 would be a constant. So according to n, I'm naming it as Bn because for every n, the constant would change, right? So I'm writing it as Bn sine nx cos nct, right? So now till here, the question was seen. This is the extra condition given to us. The condition is ux comma 0 is equal to x. So let us apply it. So x is equal to summation n going from 1 to infinity bn. Put t equal to 0. So we will get sine nx. So now we need to calculate this Bn coefficient. Now what is this? Can you see that this is a Fourier sine series, right? With Bn. So what will be Bn then? Bn will be 2 by L. L is pi, length of the string. 0 to pi. What is my function? X into coefficient sine nx. So I can apply the UV rule. So we will get x integration of sine nx is minus cos nx by n, then minus 1 integration of minus cos nx would be minus sine nx by n square, limits from 0 to pi. So that will give you, this term will become 0, right? And this term will lead to us as 2 by pi n with a minus sign, and then when I put pi, I will get pi into cos n pi, which is minus 1 raised to power n, and when I put 0, I will get minus 0, right? So pi and pi gets cancelled. We will get minus 2 into minus 1 raised to power n divided by n. So what is your u then? U comes out to be summation n going from 1 to infinity. The value of Bn is minus 2 into minus 1 raised to power n divided by n into sine nx into cos nc. So this will be the solution of your wave equation, right? It is long, but it is not difficult if you do it conceptually, right? I hope you have understood the solution of a wave equation, right? So do try this problem. So in this problem also you will find that the last condition is changed. So accordingly do the problem, right? And let me know whether you were able to solve it. So if you like the video, do hit the like button. And those of you who haven't subscribed my channel, do subscribe my channel to get the latest updated video. Have a nice day and thank you.